Let's start by looking at this deck and determining how we are going to do the structure for it. We're going to focus for now on this 18 by 20 space here. So number one, we need to put a beam at the end of the deck to hold the end of the deck up. And typically we do that a maximum of 2 feet from the end of the deck. So that being said, if we do that, we know now that this distance is 18 feet. Okay, so what we have to do is determine whether or not that span meets code. So we go into our Cambridge span limit tables and we get rid of some of the stuff that's here. We're going to ignore the 24-inch spacing for now. But if we take a look at this table, we have to see if there's any span numbers in here that are greater than 18 feet or 18 feet. And the largest one we have is 17. We've already talked about that. So we know that this does not meet code. So that means that what we have to do is we have to put another beam in there. So let's put another beam in here. And let's make this spacing 10 feet and make this spacing 8 feet, because 8 and 2 is 10 and 10 is 20. All right. So now this should work. We just got to check that it meets code. And this is what we call, this is our joist span. So this joist is spanning from the house wall to this first beam 10 feet, and then it's spanning 8 feet from this beam to this beam. So let's check code, make sure that works. And if we take a look at this, we need to find numbers above 10 and then above 8, right? So we know that 2 by 6 at 16 inches will span greater than 8 feet, okay? And all the other numbers are greater, so we could use 2 by 6s, but the only time a 2 by 6 spans greater than 10 is when it's 12 inches apart from each other. I don't really like using 2 by 6s for deck structure. I like using 2 by 8s at least. And there we have our 11 foot right there, 11'9". So we're definitely 2 by 8 structure is definitely an easy one to use. So 2 by 8 at 16 inches on center gives us a max span of 11 feet. And that's just with strapping. If we go to bridging, we're at 11'9". Okay. So go back to our deck. We know that works. So that's going to mean that our joists here are 2 by 8s at 16 inches on center, and that's a max span of 11 feet, 0 inches. Okay, so that's done. That's what we know about our joists. 2 by 8, 16 inches OC, max span 11 feet, 0 inches. So now what we want to do is determine our post, our beam size, right? So determine the size of this beam and the size of that beam, what material we're going to use for that. Okay, so if we go back to our span limit tables, okay, our beam size, 2 by 8, 2 ply, 3 ply, is determined by its bearing length, okay? And the bearing length refers to half the joist span, so half of this joist span, half of that joist span, plus the overhang. So for this first beam, the bearing length is going to be half of this joist span, which is 4 feet, plus the overhang, which is 2 feet, so that's 6 feet. If we look at this beam, the bearing length is going to be half of this joist span, which is 5 feet, plus the other half of this joist span, which is 4. So that's a total of 9 feet. Let's get that out of the way there. Okay, so keep in mind those two numbers, right? So either way, we're looking at this table here for the first beam and this part of the table for the second beam. These numbers here are the spacing between my posts or the beam span. So if the beam spans 7'9" that means my posts can be 7'9" apart. Let's go back to our drawing. We do the same thing with the posts that we did with the beam. We start by drawing them in. We can put a post here. We make that 2 feet from the edge, and this 2 feet from the edge. That means that this distance is 14 feet, because the deck is 18 feet wide, minus 2 is 16, minus another 2 is 14. Okay, so we go to our table, and we have to see if there's a number in here that is 14 feet or greater. And if we take a quick look, there's nothing. 13'6" is the largest beam span we can have, or the largest post spacing. So beam span and post spacing are the same, which means we have to add in another post. So let's put in another post. Let's get rid of this dimension. And now those dimensions are 7 feet. Okay, so now our beam is spanning 7 feet from structural member to structural member, post to post, or the post spacing is 7 feet, however you want to think about it. Go back to our span limit tables, get rid of all these circles. Okay, we are looking at this line here for our first beam because it has a bearing length of 8. And we can see right here that we can certainly span 7 feet or greater by using a 2x8 2-ply beam. It'll span 7'9". So that's what that beam is going to be. So this beam is going to be a 2x8 2-ply with a 7'9" span. Okay. Now, for this beam here, our bearing length is different. So we can't use that beam because now we're dealing with this line right here. And we can see here that our 2x8 2-ply beam only spans 6'9". But our 2x8 3-ply beam spans 8'6". So I like keeping my beams the same length. It makes it easier to work with, means all my posts are the same height. I'm working with the same measurements. So we're going to use this beam, 2x8 3-ply beam, for that second area because it's a 10-foot bearing length. I could use a 2x10. I could use a 2x10 3-ply. I could use a 2x12 2-ply, but it doesn't make sense because this is enough. So we go back to the deck, and now we know that this is a 2x8 3-ply with a span of, what was it? 8'6". 8'6" span. So I'm going to use that same post pattern back here. Just makes layout and everything like that very easy for the contractor. And that's how I lay out the deck in terms of its structural information. So I know that beam 1, which is the one close to the end, is a 2x8 2-ply, 7'9" span. And beam number 2 is a 2x8 3-ply, 8'6" span. I also know information about my posts. My posts are 2 feet from the ends and 7 feet apart. 3 per beam. And the last part about all this is, of course, figuring out my footing dimension for underneath my posts. And to do that, we go to our table, and that's up here. And we know that the floor area supported is actually the bearing length multiplied by the post spacing. Right. So if we go to here, beam number 1 has a bearing length of 6 and a post spacing of 7, which means 6 times 7 is equal to 42. Beam number 2 has a bearing length of 9, post spacing of 7. I have 9 times 7 equals 63. So it looks like I'm going to have 2 possible answers here, 42 and 63, because for 42 I'm looking right here, and 63 I'm looking right here. So my front ones are going to have a 13-inch sonotube or 13-inch hole for concrete. My back ones will have a 15-inch hole for concrete. And that's how you determine all the information you need to know about your deck. So this is a 13-inch footing, and this is a 16-inch footing. And that's how you go about determining your structural members for a deck.